Have you ever just stood on a coastline and wondered how it all got there? I mean, it seems so permanent, right? So solid. But the truth is, our coasts are in a constant state of flux, being sculpted every single second by the powerful and honestly artistic forces of the ocean. So, let's get into how that actually happens. Okay, so let's start with a question for you. What on earth could a huge, dramatic, rocky cliff possibly have in common with a gentle, sandy beach? They seem like total opposites, don't they? One looks like it's being torn down, while the other looks like it's being built up. Well, the fascinating answer is that they're both created by the exact same force, ocean waves. It really all just depends on whether those waves are in a destructive mood or a creative one. And it all boils down to these two opposing forces. On one side, you've got these high-energy waves that cause erosion, a totally destructive process that carves up the coast. And on the other side, you have low-energy waves causing deposition. That's the constructive process that builds it all up. Honestly, every single coastline on Earth is basically a battleground between these two forces. First up, let's look at the more dramatic side of the story, the carving. This is where the ocean acts like a relentless sculptor, armed with a really powerful chisel. So the main tool for all this carving is something called hydraulic action. And it's pretty much what it sounds like, the sheer, raw force of water breaking solid rock. Just imagine a massive wave smashing into a cliff. It forces air into tiny little cracks at immense pressure. And that compressed air, it acts like a wedge, literally blasting the rock apart from the inside out. Now, do that millions and millions of times. And yeah, you can bring down a mountain. And to really see this in action, let's follow the pretty dramatic life cycle of a headland. One of those big pieces of hard rock that juts out into the sea. And this just lays it all out perfectly. First, the waves attack any weakness they can find, any little crack or fault. Then, hydraulic action gets to work, widening that crack into a sea cave. Over thousands of years, that cave might just punch all the way through the headland, creating a spectacular sea arch. But the ocean isn't done yet, not by a long shot. The roof of that arch eventually collapses, leaving this lonely pillar of rock called a sea stack. And even that poor stack is eventually worn down to a stump, something you can only see at low tide. It's a whole life story right there, from a magnificent headland to just a little remnant. And hey, if you ever want to see a real-life sea stack, look no further than the Old Man of Hoy up in Scotland. It is a perfect, totally awe-inspiring example of one of these isolated rock pillars just standing there as a temporary monument to the land that used to surround it. Of course, the ocean's chisel leaves all sorts of other signatures behind. You get those constantly retreating cliffs and the rocky wave-cut platforms that sit at their base. You get these classic coastlines with alternating headlands and bays, which is just where soft rock has been carved out way faster than the hard rock next to it. And sometimes you even get these amazing things called blowholes, where water shoots straight up through the roof of a cave like a geyser. Okay, so that's how the ocean destroys. But what about when it decides to create something? It's time to look at the ocean's gentler side, where these calmer, low-energy waves aren't carving land away, but patiently building it up grain by grain. Now, the engine behind all this construction is a process called longshore drift. See, waves almost never hit the shore straight on. They usually come in at a bit of an angle, but then the water just washes straight back out, thanks to gravity. This creates this constant zigzag movement for every single grain of sand, which basically turns the entire shoreline into a massive conveyor belt, always moving material down the coast. So what does this huge conveyor belt actually build? Well, it creates some of the most famous coastal features we know and love. Beautiful beaches, obviously, but also these more complex and fascinating structures, like spits, bars, and tombolos. A spit is what happens when that conveyor belt of sand suddenly hits a corner or a river mouth. The coastline changes direction, but all that sediment just keeps on going, building this long, narrow finger of sand out into the open water. And sometimes the end even gets curved by the wind and the waves, which forms what we call a hooked spit. So what happens if that spit just doesn't stop? Well, if it has enough sediment to work with and the conditions are just right, it can grow all the way across the bay, connecting one headland to another. This creates a bar, and it traps a whole body of water behind it, forming a really calm, protected lagoon. And for our final creation, we have the tombolo. This is a special kind of sandbar that forms when that conveyor belt of sediment ends up connecting an island to the mainland. A fantastic, and I mean huge example, is the famous Chesil Beach in the UK, which is a massive timbola that stretches on for miles.
All right, so we have carving and we have building. But what's the deciding factor here? Why is one coast a rugged, cliff-lined landscape and another is just a series of smooth, sandy beaches? What gives?
Yeah, this table pretty much breaks it all down. The number one factor is wave energy. High energy means erosion. Low energy means deposition. It's as simple as that. Then, of course, you've got rock type. Hard rock like granite is going to resist the waves, and that's where you get your headlands. Soft rock like clay gets carved out super easily, and that's how bays are formed. And finally, a huge factor, especially today, is sea level rise. This basically gives the waves a higher platform to launch their attacks from, which is accelerating erosion all over the world. Okay, so this is all really fascinating geology. But why does it actually matter to us, in our daily lives? What's the real-world importance of these living, breathing, changing coastlines? Well, these features are way more than just pretty scenery. They drive tourism and support entire economies. They create these critical habitats, like the calm lagoons and salt marshes that form behind spits and bars. They're also like a history book, holding clues to what sea levels were like in the past. And most importantly, if we want to live near the coast, understanding these processes is absolutely essential for smart planning and management. So the next time you visit the coast, just remember this. You aren't looking at a static landscape. Not at all. You are looking at a single snapshot in a vast, constantly unfolding story of creation and destruction. A story that's been going on for millions of years and will keep going long after we're all gone. And all of this leaves us with a final thought. As our planet changes and sea levels continue to rise, that delicate balance between erosion and deposition, well, it's shifting. So the real question for our future is, which kind of coast will we be living on? One that's building itself up, or one that is slowly but surely disappearing back into the sea?